We've got a container with a window in it, and inside is a sample of neon. And we're zooming in so much that we can actually see the individual atoms. That's what each of these blue circles represents. So right now we are looking at it in solid form. The atoms are very close together. You can see that they have energy because they are vibrating back and forth, but they're not really breaking out of this shape. That fits with what you've learned about solids in the past. It's a substance with a rigid structure that retains its shape no matter what container it's in. If we heat the sample up, we can get it to undergo a phase change and become a liquid. The first thing you probably notice is that it is a completely different shape. That solid block that was keeping its shape is now a big jumble and mess all along the bottom. This is why we say that liquids don't keep a definite shape. Instead, they take on the shape of their container. Now, keep your eye on just one particle, and you'll notice that it's not just stuck in the same spot. It can move more. It's still staying really close to its other atom friends, but it's not just stuck in one rigid shape. That's also a definite part of being a liquid. An important thing to notice when we went from a solid to a liquid is that the particles themselves didn't change. These are still neon atoms. It's just that their spacing and ability to move around have changed. Now, if we add even more energy to the atoms of this liquid, they're going to start moving faster, and that's going to enable them to move farther apart. Now they have so much energy that they're not stuck next to each other. Gases can fill not only the bottom part of a container, but the whole container itself. Watch one atom now. You'll see that as it's traveling, it eventually will collide with other atoms. Those collisions can either give it more energy and make it move faster, or the atom can transfer energy away and slow down. So if we're looking at the atoms of a substance, you can tell a solid because the atoms stay pretty much in the same spot and just vibrate in place. In a liquid, they stay really close together, but they have enough energy to move around a bit. And in a gas, the particles have so much energy that they can move very far away from each other and spend most of their time not in contact with any other particles. To recap, in a solid, the particles are stuck in a rigid shape, tightly packed with other particles. They have enough energy to vibrate in place. In a liquid, the particles have enough energy to move around, but they stay close to other particles. In a gas, the particles have so much energy that they break free from each other and fill whatever container they're in. They spend most of their time not in contact with other particles, but occasionally they collide. In all three states of matter, the particles themselves stay the same. It's just their spacing and amount of energy that change.